Okay, we're going to test the differential pressure of the second check. Close, close, open. Okay. Close, close, open, open. Close, close. In the bucket. Bleed my high, bleed my low. Bleed the high, bleed the low, take my green. I should have a differential pressure of 1 or greater. Now, why do we measure? What's the importance of measuring the differential pressure of the second check valve? We back pressured it, it was working.
He's testing the spring.
Yeah, we want to check the spring out to see if it's working. Also, what else does this tell you? Say I test this, right, and all of a sudden, I get 0 differential pressure. What's that telling me? What's causing this to have a differential pressure? The spring. So I'm testing the spring. Okay, A, it could be the spring is bad, or it could be back pressure. Two things, all right? How do you know, or how can I eliminate one of those possibilities? You could take it apart, right, and look to see if the spring is broken there. But there's something easier to do.
Create one of
There you go. Put the pressure gauge on 1. Put the pressure gauge on 4. You take your reading. If 4 is higher than 1, what's that telling you? Your back pressure situation, it's not the spring. If 4 is lower than 1, what's that telling you? It's a spring, it's not a back pressure situation. How easy it is to eliminate that possibility with just the use or understanding of pressure. Yeah.
Can we still have back pressure even though we proved that there was a no flow?
Yeah, that's my
Yeah.
question too.
Did that meaning that the second valve had failed?
This is why you do this. This is why you measure differential pressure. You could test an RPZ with a back pressure situation. I go through all my steps. I don't test the differential pressure of the second check valve. I tested that under a back pressure situation. It still works. Everything works up to here. Small T5, T2. Why? Because water's not flowing anywhere really, because it's holding it back. It's holding that second check valve back.
Well, so you really weren't testing it, it was a backflow, so you really gotta do the last one.
You got to do the last step in order to complete that. If you're the public health person, maybe you don't have to do that. If you're the maintenance person, or if you're there trying to troubleshoot something, you got to do the last step. You got to find out whether that second check valve is working properly or not, whether it has a spring in there. Or on the other hand, what else is that telling you? If I put my gauge up here, and this gauge is higher, reading is higher here than there, what else is that telling me?
The downstream shutoff is bad.
Yeah, this downstream shutoff valve is leaking. Okay, so I know now what's wrong with it. Okay, now I know this. The second check valve is okay. Second check valve was okay when I did my differential pressure. We got a 0. Then I eliminated that by putting my pressure gauge on there. It's back pressure, not the spring, so I don't have to go out and buy a spring. What do I have to go fix now? My downstream shutoff valve. There's nothing wrong with the device. There's something wrong with the downstream shutoff valve. So that's why we do this last step. This procedure, and our differential pressure is 1. What's that telling us? We're okay. We have a good spring. We do not have what? Back pressure. Do we know if our downstream shutoff valve is holding tight?
Yeah.
No. No, we don't.
Because if nobody's using
No one's
anything,
using
it's
any
the same
water,
thing.
it's still going to be in a no-flow condition. So what do we need to do to if you're the troubleshooter guy, right? You're the troubleshooter, you need to open up something downstream. Create a flow. And then, if you create a flow and you're back over here with your no-flow test, your needle should drop or stay steady.
do the rundown on the broken spring scenario and what?
Sure. Okay, I'm at this point right here. Okay. If I have a differential pressure of 1, I'm all set, there's no problem. Okay? That means the spring's okay, and that means I don't have a back pressure situation going on. It goes to 0. That means there's two things. This spring is bad, or I have back pressure and that downstream shutoff valve is leaking bottom. Because the pressure here is going to be what? Say 100 pounds, and this will be, say, 85 pounds or something like that. So that's going to give me 0 differential pressure. Or a good way to eliminate that one of those possibilities is to take your pressure gauge. Take your reading here and take your reading here. If this reading is higher than that, then this is the problem.
Getting flow.
You're getting backflow. If this is lower than that, this is the problem.